I'll now move on to describing the features of the F600X1. The F600X1 features a highly rigid structure achieved by dividing the x-y axes travel range so that the x-axis moves on the column side and the y-axis moves on the table side. The stress path shown in the figure indicates the distance from the machining point to the spindle. Deformation of the machine is less as the stress path is shorter. So, we strive to shorten this stress path more than that of general BT30 machining centers to achieve high rigidity. To enhance the rigidity, other structural improvements have been made to the F600X1. For machine tools, connecting sections such as ball screws greatly affect the rigidity. As a measure for this, we increased the guide and ball screw sizes for the F600X1 from those for the previous model. We also increased the inner diameter of spindle bearings and the table thickness, and redesigned the cast base to achieve high rigidity. As a result, the total machine weight has increased by almost 1 ton, compared to the previous model. The F600X1 high-rigidity model enables stable machining of difficult-to-cut materials. As shown in the graph, the F600X1 can minimize vibration more than other models in a wide range of machining conditions due to its highly rigid structure. This makes machining under higher conditions possible. After this, I'll show you a demonstration of machining difficult-to-cut materials. Using a Phi 80 facemill, stainless steel and pre-hardened steel are cut to 56 mm in width and 2.5 mm in depth. You can confirm stable cutting performance and sound even under these conditions. The next demonstration is cutting titanium alloy and Inconel. You may not think of cutting these materials using a BT30 spindle, but our F600X1 achieves stable cutting using a Phi 50 high feed mill. The next demonstration is cutting using a Phi 10 end mill. Difficult-to-cut materials are cut to 3 mm or 1.5 mm in width and 20 mm in depth. Stable performance is achieved even for cutting under L/D equals 2D conditions where vibration tends to occur. Replacing BT40 spindle machines with our F600X1 can greatly reduce power and air consumption and machining time. This leads to reduction in CO2 emissions and electricity costs at customers' plants. These graphs show the results of measurement. When the BT40 spindle machine and the Speedio are run on the same machining program, there are great differences in cycle time, power consumption, and air consumption. I'll now move on to describing technologies that achieve reduction in energy consumption. While general machining centers use an induction motor for the spindle, the Speedio uses an IPM motor. IPM motors are highly efficient and consume less power than induction motors. A power regeneration system is incorporated in the Speedio so that the energy generated when the motor decelerates is collected to be reused. This achieves high power regeneration rate with less power consumption. Measures to reduce air consumption have also been implemented. For example, a structure that greatly reduces air consumption has been created through repeated spindle air purge analysis. Spindle air blow is performed only when required by discharging sufficient air at the best time. I'll now describe the high productivity. Both the Speedio machine and NC have been developed in-house to thoroughly eliminate any waste. Magazine indexing is performed simultaneously with positioning during ATC. Any wasted ATC operation is eliminated, and positioning is optimized. These technologies, based on machine-controller integrated development, have achieved high productivity. High productivity means finishing workpieces in shorter time, and this reduces operation time, leading to less power consumption. I'll now describe the machining area of the F600X1. Travels are 600 mm for X-axis and 400 mm for Y-axis. The size of the table work area is 800 mm in width and 400 mm in depth, and the maximum loading capacity is 500 kg. The F600X1 provides a machining area and loading capacity equivalent to BT40 machines. While maintaining the conventional compactness, the door opening width of 845 mm is secured for the machine width of 1800 mm.